Okay, so we're going to continue with 12.3, surface area of pyramids and cones. So before we get to the formulas, let's look at the characteristics for a pyramid. So a pyramid, if you recall back to prism, all the lateral faces were rectangles. With pyramids, all the lateral faces are triangles now. And so we still have a base. A base is always going to be a polygon. All right, in this case, it looks like a square. The base does not have to be a square. It can be pretty much any type of polygon. Again, I said the lateral faces are triangles. All of the faces except the base intersect at one point called the vertex. So right here, that will be our vertex. The height is the distance basically from the vertex to the base. So often when you think of the height, you think of that distance that's going to go right through the center. So although you can have the vertex, we can have the height shown outside of the pyramid, but we're thinking of taking the segment from the vertex to the base. And that height, just like with any height, has to be perpendicular. So it has to be perpendicular to the base. Then we have another type of height, and that's the height of each lateral face. The height of each lateral face is called the slant height. So the height, the altitude of the pyramid is inside. So we really want to use the altitude is used when we are trying to find volume, because volume is what's on the inside. So we have to introduce this other type of height, and that's the height along the outside. It's the height of one of these triangles. We call that the slant height. And so the slant height is used with surface area. Because surface area, we think of what's on the outside. The slant height, we are always going to refer to the slant height with an L, because the altitude or the height, we're going to use an H. So I'll use a cursive letter L so to distinguish slant height. Okay, so let's say we are looking at just the lateral area of the regular pyramid. So if you imagine, it would just be taking these rectangles, right, and opening them up, or sorry, triangles and opening them up. And if we were to add the area of all the triangles, right, if you picture one triangle, the area would be whatever the side is, right, times the slant height divided by 2. So if you add up all the sides, right, so for all of them, you'll have the perimeter. And I have it written as perimeter times the slant height divided, or times 1/2. You could also think perimeter times slant height divided by 2, same thing. So then if we're looking for the total surface area, we would take the lateral area and just add the base. Now with a prism, right, we had 2 bases. With pyramids, obviously we only have 1 base, so it's going to be B plus 1/2 perimeter times L. Again, you can just write that as B plus perimeter times L divided by 2. So this is surface area of a regular pyramid. Okay, here we have a square pyramid, meaning the base is a square. So just like when we were doing the prisms, okay, it's helpful to think, okay, what's my formula for surface area? It's area of the base plus perimeter of, and again, perimeter, the capital letter P represents perimeter of the base. And then we're going to take that multiplied by slant height, divide by 2. So the area of the base, well, it's easy when this is a square, right? Because this will be 16 and 16. So it's going to be 16 squared. The perimeter of the base, again, it's a square, and if you have 4 sides, 16 times 4 is 64. The slant height is actually shown to us here, so that's going to be 12, and then we're going to divide by 2. So go ahead and type that all into your calculator. And I get 640. So 640 square centimeters. Okay, another one with a square base. If you want to pause it and see if you get the same answer as me, go ahead and do so. Surface area, so area of the base. So that's just going to be 4 times 4, which is 16. Plus perimeter of the base, so that's going to be 4 times 4 again, which is 16. And then now this time I don't have the slant height. So if we look here, 7 is actually the height because it goes right down the center. So what I need to do is construct a right triangle, okay, and here will be the slant height. And if this is cutting right in half, this base will be 2. So over on the side here, I'm going to do 2 squared plus 7 squared equals L squared. So I have 4 plus 49, so I'll get square root of 53 for L. So I'll just leave it like that here, and we'll type it in at the end, and then we're going to divide by 2. So 16, and then add that all in, and I get 74.24. Okay, next one. Find the surface area of the regular pentagonal based pyramid, round to the nearest hundredth place. Okay, so if you recall in the last lesson, sometimes if you have a regular polygon, it's helpful to kind of just draw the base if you need more space or need to visualize that. So with a pentagon, okay, we're going to have to do perimeter times apothem divided by 2. So I know each side is 6, so what I'm going to do first is I'm going to draw the apothem. Now remember, central angle 360 divided by 5, that's 72. Cut it in half, and that makes this 36. Now if each side is 6, then half of that will be 3. So I'm going to have to use trigonometry. So I have tangent of 36 equals 3 over a. So that means a is going to be 3 divided by tangent of 36. So I get 4.13. Okay, so my surface area, we need to have the area of the base. The perimeter of the base, well, it's a pentagon, so 6 times 5 will give us 30. And the area of the base is going to be perimeter times apothem divided by 2. So I'm going to multiply that out, and I get 61.94. Again, I had that previous answer in there, so I just multiplied it out. So now my surface area, I have the area of the base plus the perimeter, which is 30, times the slant height, and they actually provide that to us, so that's 10. I want to divide by 2. So we have 61.94 plus 150. I get 211.94, and that's going to be square feet. Okay, next one. We want to find the surface area of the solid composite of a cube and a pyramid, round to the nearest hundredth place. So composite, we did composite area in the last chapter. It just means a combination of 2 or more figures. So what we want to think about is there's a pyramid sitting on top of the prism, which means this base is on the inside. It's not on the outside. And keep in mind, when we're doing surface area, we only want what's on the outside. So there's 2 ways to do this. We could do the area of the pyramid and the area of the prism. And we would just have to subtract the base of the pyramid and the base of, one of the bases of the cube. The way I'm going to do it, though, is I'm going to just kind of look at it all together. So the first thing, let's look at the base, and it doesn't matter whether you're looking at this base or this base, they're congruent to each other, right? So the perimeter of that base, since it's a cube, that means each side is 8. So the perimeter of that base is going to be 8 times 4, which is 32. The area of the base is going to be 8 times 8, which is 64. And then I see here 6 on the pyramid. That's going to be referring to my slant height. Okay, so the surface area, let's look at the pyramid. Now, the pyramid, normally for a pyramid, we would have, right, we would have the area of the base plus the perimeter times the slant height divided by 2. However, what did I tell you about this base? The base is on the inside, so I'm actually not going to count that base. And then I want to add the area of the cube or the prism. There's 2 ways you could do it. You could see, all right, each face is 64, and you really only have 5 of those showing, so you could just do 5 times 64. Or you could look at, right, you normally would have 2 bases plus the perimeter times height. 2 bases plus perimeter times the height. But here, that's 1 base. Here's the other base. Again, one of the bases isn't even showing. So I really don't have 2 of them, I just have 1 of them. So I'm really just going to do perimeter times the slant height divided by 2 plus the perimeter times the height divided by 2. Oh, I forgot my other base. Plus 1 base plus perimeter times height. So I have the perimeter is 32, slant height is 6 divided by 2. Area of the base is 64, perimeter is 32, and the height, and that's referring to the height of the prism, is 8. So go ahead and plug all that in. So we'll get 96 plus 64 plus 256. And we get 416. And that's going to be, oh, we don't have any units, so we'll just say square units. Okay, so now we just want to look at cones, circular cones. So similar to the pyramid, we have a vertex. We only have 1 base, so the base is going to be that circle. The height, right, is going to be the perpendicular segment from the vertex to the base. So notice the height is going right in the center. Again, the height is always going to be used with volume. And then the slant height is going to be used with surface area, just like we looked at on the pyramids. Okay, so slant height still here. One nice thing about the relationship between R, H, and L, that will always be the same. If you notice, you have a right triangle. So the relationship between the radius, the height, and the slant height is always going to be R squared plus H squared equals L squared. Okay. So again, that slant height is the segment along the edge. Okay, lateral area of a cone. So similar to what we had on the pyramid, it was the perimeter times the slant height divided by 2. Now we have circumference, right? Circumference times L divided by 2, or times 1/2. And then keep in mind, what is the circumference? It's 2 pi r. So what would happen with the 1/2 and the 2? It would just cancel, right? So it would just end up being pi r L for for the lateral area. And then if we're finding the total surface area, we just want to include the area of that circle. So that's where we get pi r squared plus pi rl, or just like we had previously, we can also write it with the area of the base plus circumference times the slant height divided by 2. The nice thing about, again, the cone and the cylinders, it's just plugging into that formula. And if you have to use Pythagorean theorem, that's just one added piece. So surface area here, pi r squared. Let me just write it out. Pi r squared plus pi rl. So I have pi times 4.7 squared plus pi times 4.7 times 13.6. So plug that in. I get 22.09 pi. Again, we're rounding to the 100th place, but if you were asked to do exact form, you would not include the pi when you multiply it on your calculator. So I would have 22.09 plus 63.92, so 86.01, and then I multiply that by pi, and I get 270.208, so that would be 21 square centimeters. Okay, the next one, if you want to try a couple of these on your own and check back, you can pause it. With this one, I noticed 7 is referring to, looks like 7 is referring to the height, so we have to figure out what the slant height is. So I have 6 squared. Remember, it's always going to be the radius squared plus the height squared equals L squared. So 6 squared plus 7 squared equals L squared. 36 plus 49 is 85. So L is going to be square root of 85. So my surface area is going to be pi r squared, pi times 6 squared, plus pi times the radius times the square root of 85. So go ahead and plug that in. And I get 286.882, so 0.88 square inches. Okay, one more of these. So 15 is pointing to all the way across, so that looks like my radius is 7.5. I need to find L. So I'm going to have to do Pythagorean theorem. So I have 7.5 squared plus 15 squared equals L squared. So let's see, we get 281.25, so that means L is square root of 281.25. So my surface area is pi times 7.5 squared plus pi times 7.5 times square root of 281.25. So plug that into your calculator. And I get 571.86, and that'll be square centimeters.